So what if you could shield an entire city from a full-blown nuclear attack with a giant balloon? Sounds crazy, right? Well, today we're diving into a research paper that proposes exactly that. It's called the Inflatable Nuclear Shield. All right, let's really get into this. The whole idea here, the core of this research paper, it really does sound like something straight out of a sci-fi novel. I mean, it's asking a pretty wild question. What if the best way to defend against one of the most terrifying, most complex weapons humanity has ever built is basically just a giant, high-tech bubble? But, an idea this out there doesn't just pop up out of thin air. It comes from a very real, very dark place. It comes from looking at the absolute worst-case scenario. So to really wrap our heads around this giant bubble shield, we first have to face the terrifying power of the bomb it's designed to stop. Okay, so let's get real for a minute and ground ourselves in that reality. We're not talking about some abstract global thermonuclear war here. No, the paper drills down on something much more specific and, honestly, much scarier: the destructive power of just a single weapon hitting a single city. And to put that power into perspective, just think about this. The energy a nuke unleashes is literally millions of times greater, gram for gram, than a conventional explosive like TNT. So we're not just talking about a bigger boom here. It's a completely different league of destruction. It's on another level entirely. The paper really breaks down this destructive force into three horrifying rings spreading out from the center. First, in a circle stretching 2.3 kilometers out, you've got a lethal dose of radiation. Then you go out to over 6 kilometers, and the sheer force of the blast wave will flatten pretty much every building in its path. But the heat, the thermal radiation, is what travels the farthest, causing third-degree burns on anyone exposed up to 12 kilometers away from ground zero. It's just devastating. And look, this isn't just numbers on a chart. This has happened. When you look at the images from Hiroshima, you see the real-world result. A massive firestorm just exploded across the city in less than 20 minutes, adding to the horror of the initial blast and basically incinerating anything that was left. This is the exact nightmare scenario that the inflatable shield is trying to solve. So when you're faced with a threat like that, what do? What are our current defenses? Well, we've thrown a ton of money and brain power into some really high-tech solutions. But as we're about to see, they're incredibly complex, insanely expensive, and, well, they're not exactly foolproof. I mean, take the most famous example, the Strategic Defense Initiative, better known by its nickname, Star Wars. The vision was straight out of science fiction, a network of satellites and lasers in space that could shoot down missiles. Sounds amazing, right? But the reality was, even after spending hundreds of billions of dollars on research, it never actually got built. It was just way, way too complicated. And that really gets to the heart of the paper's argument against our current approach. The author basically says that these systems are very complex, they require very high technology, and, he puts this in all caps, they are very expensive. That's the core problem he's trying to solve. So it's exactly that problem, the insane cost and complexity, that pushes the author to propose something completely different, a truly radical alternative. Instead of trying to fight super high-tech missiles with even more high-tech defenses, the idea is to pivot, to do something totally unexpected. And here it is, the A-dome. Okay, so what is it really? The concept is actually shockingly simple. Imagine a huge, transparent, but super thin film. You basically inflate it like a giant balloon over a whole city, and it's held up there, about 15 kilometers high, by just a little bit of extra air pressure pumped in from the ground. That's it. All right, I know exactly what you're thinking right now. Hold on. How in the world is a thin piece of plastic supposed to stop a hypersonic nuclear missile? And that's the genius of it. The secret isn't trying to stop it like a brick wall. The secret is to break it, using a really clever two-step defense. Okay, here's how it works. First, the warhead, traveling at insane speeds, slams into the thin film. That impact, even with a flimsy-seeming material, creates an absolutely massive and instantaneous G-force. The whole idea is that this jolt is so violent, it just shatters all the complex, delicate bits inside the warhead. But what if that doesn't work? What if the bomb still goes off? Well, that's where the second part of the defense kicks in. The high altitude of the dome itself becomes your shield. Let's just focus on that overload for a second. The paper calculates that the moment that warhead hits the film, it would be subjected to a force of 1,900 Gs. That's 1,900 times the force of gravity. It's a colossal bone-shattering jolt that's designed to instantly turn all those finely tuned electronics and triggers inside into a useless pile of scrap metal. And this graph from the paper itself really shows you the physics behind this. You can see how the G-force, that's the vertical axis, just skyrockets depending on the warhead's mass and the film's thickness. See how those lines just shoot straight up? The forces involved become astronomical, way, way beyond anything a complex piece of machinery like a warhead could ever hope to survive. But okay, let's say the worst happens. The overload fails and the bomb detonates. This is where that second layer of defense, altitude, becomes so critical. A nuke going off on the ground means 100% destruction. But according to the paper, if you force it to detonate way up at 10 kilometers, it loses almost all of its power. Over 99.9% of the blast and the heat just fizzles out in the thin upper atmosphere. It basically neuters the weapon. But honestly, this is where the whole idea gets really, really interesting, because the dome isn't just for wartime. Maybe the most surprising part of this whole proposal is what the author suggests we could do with it in peacetime. It's almost utopian. Yeah, this is where it stops being a military shield and starts becoming like an entire environmental engine for a city. The author suggests you could use the dome to completely control the weather inside. You could turn a cold northern city into a warm subtropical paradise. You could have a totally closed-loop water system. You could even use it as a giant screen for movies or art, or mount windmills and telescopes on it. It's wild. And here's the vision directly from the author. He says the offered AB dome is also very useful in peacetime because it shields a city from exterior weather and creates a fine climate within. So you see, for him, this isn't just some weapons system sitting in a silo. It's something that should be actively making life better every single day. So you've got this incredible vision, right? A city that's safe from both nuclear bombs and bad weather. It sounds like something from a far future novel. But what about the real world? What about the bottom line? How much would this sci-fi dream actually cost to build? And this might be the most mind-blowing claim in the entire paper. You know those anti-missile systems that cost tens of billions of dollars? Well, the author estimates that a dome big enough to cover a 20-kilometer city would cost somewhere between $60 and $90 million. I mean, that's not even a fraction of the cost. It's a completely different world. And if you think the price is wild, get this. The construction is supposed to be just as simple. You don't need giant cranes or years of complex assembly in the sky. Nope. The plan is to just spread the film out on the ground, anchor the sides, turn on the pumps, and let it inflate itself. That's it. It just rises into place. So all of this leaves us with a pretty big question, doesn't it? Is this whole AB dome thing just a cool thought experiment, a piece of science fiction? Or could a radical, cheap, dual-use idea like this actually make us rethink how we protect our cities in the future? You know, sometimes the line between what's impossible and what's just around the corner is a lot thinner than we think.